Hi everyone, good morning to all. Welcome back to Google Classroom. In this session, we are going to discuss a new topic, that is construction of tangents to a circle. This method I will explain for the question exercise 11.2, question number 1. Draw a circle of radius 6 cm from a point 10 cm away from its center. Construct the pair of tangents to the circle and measure their lengths. Draw a circle of radius 6 cm from a point 10 cm away from its center. Construct the pair of tangents to the circle and measure their lengths. Here we have to draw two tangents from a point which is outside of a circle. In this question it is given that radius of the circle is 6 cm. So here the first step is we have to draw a circle with radius 6 cm. For that, take 6 cm by the compass from the ruler and draw a circle. So here I took 6 cm by the compass from the ruler. Okay, then I have to draw a circle with any center. At any point we can put the compass and draw a circle. Okay, now this is the center of the circle. Here I mark it as O. This will be the point center O. Then what is given in the question? There is a point 10 centimeter away from the center. Okay, there is a point 10 centimeter away from the center. So we have to take 10 centimeter from the center and draw a line and mark the point at the end as P. It is not given the name, so we can give any name. So here I draw a line segment with length 10 cm from the center. That point I mark as P. Okay. Now this distance is given as 10 cm. Okay. Now we got a circle and a point from where we want to draw the tangent. To which circle we want to draw the tangents, that is this circle. To this circle from this point, that we need to get first. Then next we have to get the line segment joining the center of the circle and the point. Okay, that also we get. First a circle and a point from where we want to draw the tangents. To which circle? That circle we already get. Then that center of the circle and the point we want to join. Clear? Next we want to get the midpoint of this line segment OP. To get the midpoint of this line segment OP, we want to take just 3/4. That means more than half of the distance of this line segment OP and draw the arc to up and down. Okay. From the other point O also we want to draw the arc to up and down such that the two arcs will intersect at top and bottom. Then we will get 2 points, that is we can name it as any way A, B. Here I name that as A, B. Next step is we want to join them. Now we get the midpoint of this line segment OP. That I mark as C. Clear? The next step is we have to draw a circle from this center C, midpoint of OP. From this point as center C, we have to draw a circle with radius OC. Here you should check whether this OC and this OP are equal. If they are equal, then only you will get the correct tangents. Okay, because we get the midpoint of OP as C. So from C to O and from C to P should be equal. That we should check first. Then C to O and C to P that are equal. Then we have to draw a circle. Clear? So here I draw a circle with the center C and radius OC or OP, both are equal. Clear? Now the second circle intersects the first circle at 2 points. This is a point, this is another point. Okay, then this we can write X, then this as Y. So these are the point of contacts of the tangents. X is one of the point of contact and Y is another one point of contact. Then we have to join PX and extend PY and extend. Then we will get two tangents from the point P to the circle with the center O. Okay, so we have to join PX and extend PY and extend. Now we get the tangents PX and PY. Then we have to take the measure of PX and PY. Length of the tangent means from the point to the point of contact. That much length only we should take. This we can extend to anywhere. But length of the tangent means from the point of contact to the point. Okay. So this PX and PY are the length of the tangents that we should measure by the ruler. So when we measure that, then we will get this is 8, this is also 8. So by the theorem 2, tangents from a point to a circle are equal in length. So we get same measure for these two tangents. Px equal 8 cm, Py is also 8 cm. Okay. Then we have to mark the radius. Draw the radius and write the radius too. You can write the radius from O to this point and from here to here remaining 4. Okay, radius 6, then here it is 4. Otherwise you can draw a separate radius and write the radius as 6 cm. That is compulsory. Okay. So here I draw the radius and write the measure because we want to mention what is the radius we took to draw the circle. Did you understand this? Once more I will explain the same question. Exercise 11.2, question number 1. First we have to draw a circle with radius 6 cm. Take 6 cm by the compass from the ruler and draw a circle first. Clear? Then we have to mention that radius in the circle. So this is the center O. Then we have to draw a line and mention the radius. Now I mentioned the radius here. The next step is we have to mark a point P 10 cm away from the center. So from center we have to draw a line 10 cm and mark the point P. This is the point P which is 10 cm away from the center. Next step we have to find the midpoint of this OP. To find the midpoint of OP, what we should do? Put the compass at any endpoint O or P. Then we have to take 3/4 of the distance of OP. That means more than half of the distance. Just take it as what? Approximately. Okay. Then draw the arc from P to up and down. With the same measure, we want to draw the arc to up and down from O also. Okay. Then we have to join these two intersecting points A and this intersecting point B. Just join that using ruler. Now we get the midpoint of OP as C. Okay. Now we have to take the distance from C to O and C to P. Both should be equal. Okay. Both should be equal. Here the distance from C to P and C to O are same. The next step is we have to draw a circle from C with this radius OC or OP. OC and OP are equal, so we can take either O or either OC or CP. Okay. Then we get the circle. Then this new circle intersect the first circle in 2 points that are the point of contacts X and Y of the tangents. Next step is we have to join PX and extend and py and extend. So using ruler, we joined px and extend that line and py and extend that line. Then we have to take the measure of px, that we will get as 8 centimeter, and then py, that also 8. These two should be equal. Then only our answer is correct. Okay, because as theorem 2, tangents from a point to a circle are equal in length. So here our answer is correct. They asked to give the justification for the construction. So we should give the justification. Okay. For that, what we should do? For that, we have to join OX and OY first. We have to join this OX and OY. Now we have to consider either this triangle OXP or this triangle OYP. Any one of these triangles we have to consider. Okay. Then OYP, we can consider triangle OXP. OYP also you can consider. Here I consider triangle OXP. Okay. Then here OY perpendicular to YP. Why it is OX perpendicular XP. Here we select this no. So OX perpendicular to XP. Why? That is by theorem 1. Okay, that is by theorem 1. Then by theorem 1, radius to the tangent is right angle. Now we know that OXP is a right angled triangle. Triangle OXP is right angled at X. So we can use the Pythagoras theorem. So when we use Pythagoras theorem, then what we will get? Hypotenuse square equal base square plus altitude square. So here we can write OP square equal OX square plus XP square. Here we know that OP. What is OP? 10. So 10 square equal, what is OX? O to X is also the radius. So we get that is 6 centimeter. Okay, so OX is 6 centimeter. So 6 square plus XP square. Here we have to get XP as 8 centimeter. That we want to justify. So here XP square equal 10 square minus 6 square. That is 100 minus 36. That is equal 64. So XP square equal 64. So XP equal root 64. That is 8 centimeter. So this is the justification for the construction. Similarly, YP is also 8 centimeter.